This is the Amp Hour Podcast, recorded February 1st, 2017, episode 334, an interview with Gerry Roston.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And I'm Gerry Roston, CEO of Civionics Incorporated, a University of Michigan spinout, and executive in residence at Techtown Detroit.
Welcome, Gerry.
That was a mouthful.
Yeah, that's a lot of titles. I think we have an experienced engineer here, Dave. That's what I'm thinking.
I think we might.
Yeah. It's 2 business cards, so I don't have to squeeze them all onto one.
You could do it like they do with the Chinese business cards, where it's like one side's in Chinese, one side's in English. You could do maybe just have one, the flip card, But yeah, that's great. So, Gerry, Civionics is a IoT. Is that a swear word for you or no?
No, well, I like to say IIoT. We're industrial Internet of Things. We are not trying to get into the mass consumer market. Mm-hmm. Instead, we're focused on applying our technology in various manufacturing settings to try to save the manufacturer's cost by reducing downtime, improving quality, etc.
Awesome.
Okay, so now you're allowed to stay. It's okay. If it was
consumer IoT.
Consumer Internet of Things, no.
Right.
No. Show's
Smart,
over.
What is it? Smart toasters, smart microwaves, all that crap. Yeah. Let's take a step back before we get to that, because that stuff's actually very interesting. Can we hear a little bit about where you're from, how you got started in the space, and what's your backstory?
Okay, well, it's long and boring. I'm an engineer by training.
So is this show. Sorry.
I'm an engineer by training, as you have noted. After I did my master's degree, I did my master's in 1985, and back then, computers are not what they are today. They had significantly less capability. And when we were trying to control robot arms, there were 2 ways to do it. One is what we call kinematics, where you just tell it where to go and it gets there. And the other is dynamic, where you tell it how to get there from a force perspective. In other words, you say, apply a force in this direction and get there. And the former, mathematically, is very straightforward. It's, just simple trigonometric equations. Mm-hmm. The latter, though, gets ugly. And back then, ugly meant that there wasn't enough computing cycles to be able to solve the equations. Huh. And there was a fellow at the Jet Propulsion Lab who wrote one of the seminal papers on controlling the Unimate 600 arm, which then got renamed 560 for some reasons I never could figure out. And he basically showed that if you have all these big, ugly equations and get rid of most of it, you wind up with something that works. And so what I did for my master's thesis was I went and I studied what he did, and I found that he actually eliminated a little bit too much. And in my master's thesis, I showed that if you kept a few extra terms, and by a few extra terms, it was something like 8 more multiplies and 7 more additions or something like that. Trust me, back then that mattered.
Yeah, no, of course.
Yeah.
It made a dramatic improvement in the accuracy of the output. Huh. And so when I got done with the master's thesis, I sent the paper to Tony and said, I'm looking for a job. And he said, let's talk. And I wound up working at the Jet Propulsion Lab in the robotics group in the mid-1980s.
Oh, we're going to talk about that.
Yes, we are.
Yes. So by accuracy, do you mean is it like one-time accuracy or repeatability? To go back and forth between two.
By accuracy, what I mean is the deviation from the full equation. So in other words, if I could have solved the thing fully, I would have had a certain profile. And then by using this reduced form, I was closer to the actual than what Tony's paper had, and by a significant amount with those small changes.
Okay. And so it's like an approximation, like any other approximation on. Like if you're doing fixed point math versus floating point, you have to cut off the term somewhere or something like that, right?
Correct. Yeah. So, work like that. And again, I don't know that they ever referenced my paper, but, what's his name? 30
Mike.
years ago. A fellow out at Caltech who then went up to Stanford as faculty actually used that approach so that they actually had a Puma 560 arm wiping a piece of glass that was just supported at the two ends, and they could actually wipe the piece of glass clean without breaking it because they had good force control.
Okay. Right. So that's the kind of thing you see when you go. Like, so I was at IMTS this year, and they love showing off their robots of those kind of things. They're always like super accurate. I used to work for ABB too. They'd have like, oh, we're so accurate, blah blah blah. But I'm guessing around this time, it was a much chunkier kind of approach. Is that kind of what you're getting at? It's
Yeah.
Okay.
We had some of the very first 6-axis force torque sensors on the wrists.
Oh wow.
The Puma controller was made by a company called Digital Equipment Corporation, which might be before your guys' time.
No, I know all
Deck.
about that.
I know the stories of Deck at least.
Yeah,
But these weren't the big decks. These weren't the Vaxes.
right.
These were actually the PDP series.
Oh really?
yes, the PDB-10. Yep.
Yep. No, these were PDP 11 23s and
PDP
73s.
Yep.
Yeah.
Okay.
Wait, so like relative size then? So like how much gear would it take to control this robot arm? Is it like half a room?
No, it wasn't that big. The
Okay.
PDP 11 box was 19-inch rack mountable, full depth, and by today's standards, and again, I never put a ruler to it, but by today's standards, you'd probably call it an 8U or a 10U.
Oh wow.
Yeah,
Okay.
it's around about that.
Yeah.
So,
So sizable, and it kicked off some. You probably cook a English muffin on top of it or something.
oh
right?
yeah. And it consumed significant amounts of power and had, I think, 64K of RAM or 128K of RAM or something like that.
And I bet it was
But
cheap
that
too.
was pretty much the go-to industrial computer,
Yes.
control computer back then, wasn't it?
Absolutely. Everybody had those.
Interesting.
And so one of the projects that I got involved with at the lab was, so one of the problems with robots when you do kinematic control is you say, I want to go to this position in space. You do the reverse, what's called reverse kinematics, and it tells you what angles to set the joints to.
And
then
a
you
couple
set the
people,
joints.
a couple of people just shuddered right there because they probably had to do that in their classes of doing the equations and the solving for the reverse kinetic stuff.
Oh,
right?
that's the fun stuff. I mean,
We're talking about
doesn't,
PhD here, folks. You could tell he's a PhD if he likes the math.
doesn't everybody like inverting 6x6 matrices symbolically? I mean, come on.
No.
Anyway.
Oh, no.
So the thing is, you say where you want to go in space, you do the reverse kinematics, and then you set your joint angles, but you never wind up where you think you are because of errors in the manufacturing and everything else. And there was a faculty member at one of the, it could have been USC or University or UC Long Beach, I don't remember which, someplace there, who wanted to use one of these robots to hold a probe for doing neurosurgery. And obviously
Accuracy matters.
Accuracy matters. And so the fellow I was working with,
Sorry, I can just picture it trying to get it wrong.
so the fellow I was working with figured out a way to take a robot arm, take a lot of measurements, and then use that to sort of back out what the errors in the arm are and then correct for them so you can go where you wanted to.
I was going to ask that. Can you measure it and then put that into
Yep.
the model? Put the
Yep.
real, but then that'd be unit specific, wouldn't it? Each one
Absolutely.
would have to be like
Yes.
factory calibrated, maybe
Yep.
even recalibrate on site after you move it, perhaps.
Perhaps. But we went ahead and did that, and the results were good enough that that robot was actually, I believe, the first robotic use of neurosurgery. And that came out of some work that I was involved with
Sweet.
at the lab.
That's awesome. Yeah.
We
And
also,
why is that better than a human?
well,
Is,
now
is it the repeatability and the accuracy, or do they just need so many, like more hands than what the surgeon has?
a lot of it has to do with accuracy. And back in the 80s, obviously, it was purely research. But nowadays, one of the issues nowadays, actually, just to completely go off subject, is that
That's
a lot
what
of
we do.
hospitals
We do it all the time.
are using robots for surgery when they don't have to because of reimbursement rates. But what's actually
Reimbursement? What do you mean reimbursement
Oh,
rates?
so like U.S. based healthcare and stuff like that, right?
U.S.-based healthcare. Yes, it's
because it's cheaper? Does that mean it's...
no. What
Well-
it means is that they get paid more for doing it from the insurance companies than if they do it the other way. And since in this country we have for-profit based medicine, trust me, nobody outside the U.S. understands this because it doesn't make sense to even people in this country. So,
but there's more robots because of it, so that's something, not good nor bad, right?
Right, but what's going to happen in the not too distant future is that they're not going to need the doctors anymore.
Really?
There are surgeries which can actually be done.
They can slice them open, pull it apart, stitch them back up. The whole works.
Right. Take something, air quote, simple, unair quote, like hip replacement.
Right.
That's a fairly straightforward procedure that once you have the patient locked in, you really don't need the doctor anymore. You could have the machine do the whole thing. And obviously the machine will be repeatable and won't have a hangover, not that doctors ever drink, et cetera. So, it's interesting how that whole field is going.
Right.
But isn't there variability in people's bodies
biology,
and bone?
Sure, but that's what sensors are for. That's what sensors are for. I mean, that...
Yeah, true.
I think it's the psychological aspect. So my buddy is an oral surgeon. He was talking about doing that. He's like, I want to get robots to drill cavities and stuff like that. And I'm like, look, man, that's going to scare the crap out of some people. You just can't do it. You'd have to put everybody under, but for big surgeries, of course you would, right? So,
right. I mean, it's like airplanes these days. There's no reason that we need pilots in the aircraft.
No, technically.
Right. Yeah. Now, I take that back. I mean, you need the pilots for when unexpected things happen, because that's where robots just don't do well. They can't today do things that's unexpected. So the
which is good too.
The problem with that though is that the pilots aren't very good anymore. Is what I'm hearing is because they're so automated, they don't know what to do in an emergency. That might become the same way with surgery. If they rely too much on robotics, then what happens when shit hits the fan?
Right. Well, I mean, more to the point of this show, that's happening with software developers these days.
Oh, yeah.
Again, as you guys figured, I'm an old man. And, back in the day, I actually wrote assembly code. And I remember...
So did I.
I remember doing a project for a class in my master's program where I wrote self-modifying code. Because, again, I was a robotics guy. Every cycle counted, and self-modifying code is the absolute most efficient way to do things. Needless to
one
say,
of the best ways to mess things up.
there's that little detail.
Yeah,
but
right.
The professor had no sense of humor about that. But nowadays, you talk to guys who are developing these fancy websites, and you say something like assembly code, and you get a blank look. There's some frameworks out there like Laravel, which allows you to build an entire website which is database driven without ever having to write a single
line of
SQL statement, because it abstracts all of that.
Yep.
But that's less important because it's not flying, people's lives aren't on the line kind of thing, Whereas, self-driving cars, people's lives are on the line, surgery and all that sort of jazz, planes.
Yeah.
So...
Yeah, and I think people dive down to the abstraction when they need to these days too. Like with the timing stuff, you need to have the timing perfect for. So like the people writing assembly still are the ones doing the low-level driver stuff, but then that gets pushed up the chain, right?
Right. And funny you mentioned drivers, because after I got done with that project, I moved over to start working on some of the extraterrestrial exploration projects that we were working on at the lab.
Really?
Yeah. And
that's a nice name. Where's that name on the door?
And so I learned how to program C back in 1986, and the very first thing I ever did in the C programming language was write a real-time device driver so that we could interface a PDP 1173 that was running a system that came out of McGill University. Vince Hayward put it together, and we had to interface it with our VAX. And we had a custom FIFO card on both sides. And the first thing I ever did in C was write that real-time device driver. That it worked amazes me to this day.
That's how I feel about my code most of the days. But yeah.
So let's talk JPL.
Yes.
And when you said, sorry, one step back. When you said lab, so I'm looking at your past. Was that which school was that at that lab was?
That was at the Jet Propulsion Lab, NASA.
Oh, that was at last. Oh, okay,
yep.
Great. Okay, so we're already there. Okay.
Yep.
So you were chosen as the first member of the Mars rover team.
Yeah. Well, what happened was the guy I was working for, Brian Wilcox, who was my manager, was a very savvy guy. And one of the things that disappointed me about JPL was how political it was.
Really?
Yeah, it was very political at the time. We would have arguments over, who gets to develop which part of a system. Where do we draw the line? But Brian was very savvy, and he came up to me one day and he said, "Gerry, I have a box here with 6 gear drives and 2 worm gears. Mars rover project is coming. Build me a robot so we can have lead on it." And
oh, nice. Start with the prototype, right?
Yeah.
It's easier to say.
Yeah.
We
So
already
if you-
started. Yeah.
If you Google Robbie the rover, you will find a picture of Robbie online someplace. And so that's the robot that I built. And that's the robot that all of Sojourner's software was originally developed on.
Whoa.
Oh, sweet.
Wow. And so
was
yeah,
it
go ahead.
was it advantageous to have that prototype to take to meetings and show, hey, look, we've got something, pick us.
Yeah.
Is that the
Yeah, well, JPL was the lead on it, but Brian was able to bring most of the work into his group. And then he brought on people like Andy Mishkin, who actually wrote a book about this, Donna Pivarata. That's not her name anymore. She got married. I forgot what her new name is. She was sort of the overarching program manager. There was a fellow out of headquarters by the name of Mel Montemerlo. So, the whole thing obviously got quite large when it, as it progressed and as it became an actual flight mission. But we got it all kicked off, in Brian's lab. That's where it all started.
That's great.
So what platform, what hardware are we talking about? What processor are we talking about for the Sojourner rover? Which I presume your one was the same?
No, Robbie, it was the terrestrial prototype, if you will. It wasn't even
But you said you
similar.
developed the software on it.
Right, yeah. So all of the high-level software, the planning stuff. So
Oh, okay, right.
Yeah.
Yep.
So Sojourner, for example, used a 3D display, had 2 cameras. They would come back. You'd use we used cross-polarized glasses so that you could see 3D. And the driver would use that image to pick points on the map of where the rover should go. And then it would just go straight line between those waypoints. But all of that was originally developed on Robbie, and all of the testing was done in the Arroyo right outside of the lab.
Dave knows space history much better than I do. Could you explain the Sojourner too? Like I actually don't. I know.
Yeah, that was
I know some of
before
the
you were born, I think,
curiosity.
Chris.
I get that stuff, but I don't actually know the history of that as well.
It was the first one. It was the first of a proposed fleet of robots. Was it Mars rovers, was it not?
Yes. Yeah, it was followed.
Well, the first one that made it,
Yes. Yeah. And the guy
as
who
in funded and...
Yeah.
the guy who drove it off the lander was Brian Cooper, who was a buddy of mine. And so he's actually the guy who drove it off the lander when it
Sweet.
hit the surface. Yeah.
That's
How
really
much fun
cool.
would that be? And it's not real time. It's not like you're watching the
Right,
game.
it's like go
push the
forward 4
joystick,
steps, right?
Like, it's like I'm sure it takes a day of, meetings and everything to figure out, okay, we're going to move it half a meter down the ramp,
Yeah.
Well,
But-
and how did that land? Was that the? I remember the one that bounced. I remember that one. Was this-
Airbags.
Yeah. Was this the same thing?
I don't remember what the touchdown procedure was for Sojourner. I had left the lab by that point.
Okay.
Yes, it was. It was the airbags.
It
You
was.
see them in the photos deploying. The early ones, because they didn't weigh much, they were tiny rovers, they easily fit on your desk. They're, small
Yeah.
little rovers. And they didn't weigh much, so they could use the airbag system. That's why they didn't use it for the Curiosity rover, because it's the size of a small car and
Yeah,
weighs
it's like an SUV
1.5
style.
tons,
Yeah. Yeah.
So they just, you couldn't make the bags big enough to
Right.
absorb the impact. So they had to use the sky crane, powered descent thing. But these were small enough that they figured, oh yeah, we can just bounce it. Yeah. And yep.
So,
And it works.
so,
It's
so
a
Gerry, so
reliable
I'm looking
method.
at the picture of Robbie the robot, and we'll link it in too. I mean, it looks like like you said, it has some arms, some cameras, stuff like that. But like, when you build something like this, what do you go and actually, what do you usually test for it? I mean, like, is it just proof of concept or?
Yeah, that was again. That one was really for developing the navigation software. So we
Okay.
needed a platform. The thing on the back there's a 3.5 kilowatt Honda generator, and
Oh my
that's there to
gosh.
power the VAX computer that's in the middle compartment. And those are ATV wheels that I found at some shop someplace in the area. So,
Oh man, so you're like a space prototyper. This is even cooler. It's yeah. And what time frame is this too?
this was this would have been 87-ish, 87, 88.
Okay. And so I mean, like computers were obviously improving, but this was still VAX. I mean, I don't know what the VAX ran on, but
this was pre-Windows. This was pre-Windows even.
Yeah, right.
The AT came out in the PC AT came out in 85 or thereabouts, and then in 87 or 86 we upgraded our lab to Sun workstations, the 3/50s.
Nice.
And they were really spectacular because they had, I think, 4 megabytes of memory, which
what a beast.
I don't miss those days at all. Like I know I wasn't doing much back then, but even still, like, man, I'll take as much memory as we can get these days, you know.
and of course that wasn't a single chip. That was
No, that's
a
an
full
array.
quarter of the motherboard. Yeah, it was
Yep.
something.
Wow, that's crazy.
Oh, beautiful.
Yeah, and then from the lab, I then moved to Carnegie Mellon in Pittsburgh, and joined the Field Robotics Center there, and stayed in the space robotics arena. So the focus there was actually more on walking robots, because one of the challenges with wheels in unstructured terrain is that you come across obstacles that are hard to surmount. And one of the 2 rovers, I don't remember if it was Curiosity or Discovery, actually, I think, got stuck because of the soft sand and it wasn't able to get out.
Oh, right. Yep.
And,
That's
Yeah,
crazy.
I think it was. Yep.
So
I think
when
it's still stuck there spinning its wheels.
yeah.
oh, sad. I always get so sad when I think about. There's an XKCD about that where it's just like the robot keeps thinking that it's gonna go home. I know it's a really stupid anthropomorphized, but I get so sad. It's like these little
It is
explorers,
like in The Martian, the movie, right?
Yeah.
You know that it's a sad
book.
scene where
Yeah.
like he digs up the the rover covered in sand. You know, it's
It's our science
it's
history.
just-
It's buried
yeah.
on another planet. It's crazy. Whatever happened to the Robbie the robot? Do you know?
I don't know. I know that some of the earlier robots, we were there. There's a museum in Boston called the Boston Computer Museum, and it's right next to the Boston Tea Party on the what's it called, South Bay there.
Ooh.
And
You
we
know,
actually,
a little fun fact for you. One of my relatives was throwing tea off of that boat.
so they actually came and asked us for some of the old robots. I remember prepping a couple of the really, really old ones, which went out to the museum there. But I have no idea where Robbie wound up.
That would be great to see, like one of those, like the evolution of man. That image of like the monkey like growing up into the man.
Yeah,
walking
right,
with
yeah.
But like with robots or something. That'd be
yeah,
that'd be
the
interesting
same
to see.
image. Yeah, with
Yeah.
So
That's
it's
beautiful. That's awesome though. I mean, and so it had a 3.5 kilowatt generator. It was lugging around a VAX or PDP, whatever one. Man, that's got to have some curb weight, huh?
That's terrific. Do you know how many people in the end, how big the group was who worked on the rover? Not your one, but the actual lander?
Well, I mean, when you get to a flight mission, it's I don't want to say a cast of thousands. I don't know that it's that large, but
But it's
significant because they wind up outsourcing a lot of the manufacturing. It's all custom electronics and computing at that point. So quite a few people had their hand in that final project.
Yeah.
And how many of them do they build? Just 2? One flight hardware, and is it an identical one for ground?
Again, I don't know what they did, but that is what they that is typically done, where they would build a second one for ground. Yes.
Yeah.
Right.
And so I'm looking at the picture here of Robbie the robot as well, and like they're not stepper? Are they servos? Are they steppers? Are they?
Those were servo motors on there.
Okay.
Yeah.
So, but did you have to like then go and build your own stepper drivers and everything like that too? I mean, like I kind of take that for granted these days.
We oh boy, now you're asking for details. That was
Sorry.
No, I think back then we were using so what we were doing back then is we were using single board computers based on the VME bus. And so I believe that what was in the rack was a VME based computer, and we had a tether going back to the VAX in the lab for the high level control. and the VME computer was running Wind River Systems VxWorks real-time operating system. As a matter of fact, Gerry Fiddler, who was the founder of the company, is the one who actually came down to make the sale to us, and we were one of his first major customers.
Wow. And look where they are now. That's crazy.
Yeah.
Yeah.
And but what's crazy is that entire VME computer, which was this 19-inch rack mount, the
right, single board, they mean a whole board, right?
Yeah, whole board. And Dave, you
no
might
Raspberry
remember
Pis here, folks.
the connectors on the back were 120 pins, and there were 2 of them, I think.
Yeah.
They were oh god, what's the number? The 61410.
The type of I know what you're talking about.
Yeah, the type of the connector. Yeah, 100 pins.
Yeah, I was thinking 120, but whatever, a large number. All of that these days you can buy on a microcontroller chip from Microchip for $2.50.
Yep. Yeah, that's nuts.
And run it on a AA battery.
Yeah,
it's a different world.
It's better. I'm just saying, it's better. But the work you did obviously led to that, so that's great.
Yeah.
So
arms. Can I ask about arms again and the kinematics and go in there and move in from one location to another, accuracy, all that sort of stuff? Do you have sensor feedback of positional feedback?
Yeah, absolutely. All of those robots.
Yep.
Had optical encoders on the joints.
To make sure they're not slipping, of course. So you know exactly how many steps you've moved.
Well, they weren't steppers, they were servos, so you'd have a closed loop control around the position. Yep. The one thing that people tried to do many times was to basically time differentiate that encoder signal to get a velocity signal, but differentiation is a very noisy process, and so the results from doing that were always a mixed bag.
Interesting.
Yeah. So you're saying if from one step to the next on the encoder, trying to just measure the time between them, and if there was a little bit of variation in the print or something.
Yeah, normally what you would do is you would measure the number of steps over some period of time, as opposed to the time for a single step. But as I said, differentiation is a mathematically noisy process versus integration, which isn't. So that's why you can do things with accelerometers and integrate them to get velocity and position and not have it suck terribly.
Yeah, but that's still not super fun. That your boat my buddy did that with a boat where he's like, I'm going to use an accelerometer to know how far my boat drifted. He's like, I don't know where my boat is.
Well, it depends on the accuracy and everything else. I've seen cases where, what project was that on? Doing some project where we were doing accelerometer integration, and we were drifting by meters per second.
Oh wow! Which I guess matters if you're doing. It probably doesn't matter too much for space-related stuff, but for terrestrial stuff.
Yeah, no, it does matter, and that's why you have to correct that. I mean, if you're doing stuff like that, you always want some sort of independent way to basically recalibrate your system.
Yeah, like sensor fusion stuff that happens these days, right?
Yep, exactly.
Well,
Is there any other way to, if you've got a robot arm that has a point on it and, it can go anywhere in its three-dimensional envelope space, is there any other way to get feedback of the position of that? Can you do it, can you add additional sensors to, optically sense where the end of the probe is, for example? Are they...
Sure, absolutely.
Any sort of, can you explain some different methods to augment the accuracy, I guess, or maybe verify the accuracy of what those optical encoders are telling you?
Right. And what you mentioned, doing something optically, again, has been done for a very long time. Basically, you put cameras in the field of view of where you want to go. Typically, you calibrate the cameras ahead of time.
And they'd have to be stereo too, at least, wouldn't they? But you can't just use a single camera to.
Again, depends on what you're trying to do.
What the surface, but I'm talking about sort of anywhere in three-dimensional space kind of thing.
Then you would want 2 cameras to get stereo.
Yep.
Obviously, if you have a third, you can do a better job.
Yep.
But you use the cameras then, which are calibrated, to basically reverse map where that point is in 3 space, and then you can use sensor fusion approaches. For example, something like a common
sensor fusion.
Right.
That's
So,
the phrase of the week.
yeah. So something like a Kalman filter allows you to take measurements from different systems with different accuracies, if you will, and put it together. And what's interesting about using approaches like that is the accuracy that you get out of the fused is actually better than the accuracy of either of the things coming in, typically. So it really does give some
It can be, not... Yeah, it depends on the uncertainties and everything else.
Yes.
But it can be. And the more you've got, the better,
Yep.
potentially.
Yep.
The more sensor sources.
Yes.
You've been in robotics a long time. When did you see this? I mean, so was this kind of like, was the sensor fusion stuff happening even on the Robbie into the Field Robotics Center? I mean, is that...
Well, back at JPL, one of the projects we worked on was it was going to be a free orbiting multi-robotic arm platform for doing satellite repair. And we actually had this thing mocked up in the lab where we
Sweet.
we built a satellite. It was basically 6 solar panels that I found, and I arranged them. I don't remember how I did it, but made them in a hex shape. And we hung it from the ceiling with a counterweight to go up and down and spin around and whatnot. And we had we had 2 Puma arms which could reach out and grapple this thing as it was spinning. And we had another Puma arm with a pair of cameras on it, which would capture the position and extract the velocity of this, so the other arms could actually go out and grapple it.
Fascinating.
That work was led by Don Gerry, who was one of the early guys in computer vision, a tremendously bright man.
Are they still looking at doing... Because every space repairs are done by humans at the moment, aren't they?
As far as I know, yes.
Yeah, they're still done. I don't think... I mean, they have the robotic arm, but that's only for, sort of deployment, retrieval
Well,
type
imagine
stuff.
like a
Not-
surgery, Dave, where the patient doesn't die. They burn up in the atmosphere if you mess up. Right. Yeah, having the human there is nice.
Which is worth a lot more money. Humans are cheap. There's plenty of us around.
I didn't realize... So I was just looking at Puma Arm, Gerry. I didn't realize that's actually an acronym. Programmable Universal Machine for Assembly.
Yep. And that came out of Unimate, which was Engelberger's company. And that was one of the, I think, maybe even the first commercial robot company in the world, maybe.
It was, I believe. Yep.
Yeah. That's great. That's really cool. So, well, tell us about the Robotics Center at CMU. So that was where you went to go do your PhD, is that right?
Yes. Yep. And so while there, my focus was on walking robots. You guys might know, I think it's called Boston Dynamics these days, Mark Raybert's company.
Yep.
He was at Carnegie Mellon, and then he left and went to MIT. I was in Red Whitaker's group. As I said, my focus was on the terrestrial robots, primarily statically stable walking machines. But it was the Field Robotics Center at Carnegie Mellon that actually invented most of the automated driving technologies that are now being commercialized.
That's right. And then they hired away the whole team.
They hired away the whole team. Those are all my colleagues that got hired away by Uber.
Really?
Yep.
That's crazy.
Yeah, we were the first.
By Uber?
Yeah,
Yes.
Uber, they hired them all away, Dave. The
Uber.
entire department.
Yep.
As in the car company?
Yes. Yeah, because their biggest cost right now is the drivers, so they want to get rid of them.
Yeah.
Oh, okay. I didn't know they were getting into that
Oh, yeah.
driverless.
That's such a big thing.
Yes, of
Yeah.
course they
Imagine-
are. Yeah.
Imagine,
Right.
do you remember when Uber switched from, I remember my friend pointed this out. He's like, you remember when the Uber drivers stopped asking you where you're going and you're just putting in the address directly? It's like, basically that's the first step towards removing the driver entirely,
Yeah, right,
because
the
you never
driver
have to
through
talk
the
to
thing,
anyone
right.
at that point.
Yeah.
You just get
Yeah.
in and it goes.
Yep.
So that's crazy.
So
Wow.
we were the first group to ever drive a vehicle autonomously using GPS control.
Really?
And,
Oh,
yep.
wow.
And when we did it, the GPS constellation wasn't complete. So we actually had charts up in the lab so we would know when we would have
Oh,
4
no.
satellites
Yeah.
in view.
Yes. Yeah. And if you get one satellite right on the horizon, it can throw you out. You
yeah.
actually want to ignore that puppy. Like I come from a geocaching background, and many a time I've stood between a tree and a satellite. I can see the satellite map, and I'm blocking that bastard out. It's affecting my accuracy. So yeah, you would block the thing out.
And was this before
It's
the? Did you guys have access to the full resolution? I forget what it's called. Dave's told me
No,
about
it was the
before.
degraded resolution.
Selective availability.
Yeah, it was the degraded resolution. So we would normally have 2 antennas on the vehicle, and you basically did I don't remember what we called it, differential GPS or something like that.
That's the wide area augmentation system, the WAS or whatever.
Yeah.
Yeah, that just allows you extra. They have local transmitters as well as the satellites that allow you to get additional accuracy. I'm not sure if they're still using that or not.
Yeah, this was before that. This was basically just getting 2 signals from the satellite because of the way they mucked it up. If you had 2 of them, you could actually improve the accuracy because some of the noise would cancel, basically.
Oh,
Right.
really?
Yep.
That's interesting.
Yeah, but now they've done away with that. I mean, I think everybody can get the full accuracy these days.
Right.
Yep.
And I'm guessing your antennas are probably a little larger than most cell phones these days, too, huh?
Oh, yeah. Well, the original vehicle was the Humvee.
Uh-huh.
What do we
Like
call
the
it?
big ones,
NavLab.
right?
Take a look at you can Google NavLab and NavLab 2. NavLab 2 was an ambulance model Humvee. And the reason we needed the ambulance model was the entire back of it was packed with computers, and there was room for a couple of researchers to sit there. And it would creep along at, a mile an hour type thing.
Uh-huh. That's awesome. Oh, wow. This is a big car.
Yeah. That's, originally, then they got it out on the highway. And I assume the statute of limitations is elapsed, but we were also the first group to ever
you guys were
exceed
breaking the law, right?
No, we were the first group to exceed the speed limit under autonomous control on a public highway.
Gerry, there's agents outside your house right now. This has been a sting operation. That's why we needed to know where to send a microphone.
So what is your whole take on this autonomous car revolution? Do you think it's going to be as easy as what a lot of people claim? Because I don't think so. I think there's going to be a lot of small issues which I'm not going to say are showstoppers, but are really going to put
I think the
kink in things.
I think there's really only 2 big technical issues. And I think one of the technical issues is what happens when you have some vehicles that are autonomous and some that aren't. Mm-hmm. Because one of the things that you can do with autonomous vehicles is that you can do convoying, which greatly reduces fuel consumption for the trailing vehicles and everything else. But when you have non-autonomous vehicles in the mix, you have problems. I think the other real issue is what to do in the edge cases. So when the kid, if a kid runs out in front, do you slam on the brakes to save the kid, or do you swerve?
Yeah.
And all of those
ethics.
Yeah.
Right?
Yeah. So technically, I think those are the 2 big problems. I think the much bigger problems are social problems. In this country, if we have real autonomous driving, we put 4 million truck drivers out of work.
Right.
And that's a lot more jobs than have ever gone overseas by the Mexicans or the Chinese or anybody else that Trump wants to blame. Most of those jobs are actually lost to automation.
Yeah.
And we ain't seen nothing yet.
I think automation is going to be a huge piece.
The truck drivers is where, truck haulage is one of the almost ideal, one of the best case scenarios for autonomous stuff.
Yeah.
Because they can just keep driving all day, all night, and they're typically driving in the middle of the night. There's less issues.
Right. They talk about last mile, where when you need the human in the loop, you just do it right when the delivery happens. All the highway stuff is taken out, and then you can convoy, like you said, make a train effectively.
Right. And then think about what happens when we don't need taxi cab drivers anymore.
Johnny Cab.
Right. Think about what happens when we don't have to own our own vehicles, because when we need to go someplace, it shows up. And what does that mean about?
I don't have a car anymore. That's what I do. I just use Uber and public transport. So.
Right. And what happens to the parking lot? So the societal implications are huge. And unfortunately, with the nonsense that's happening politically in this country right now, we're missing all of the important conversations and focusing on nonsense. And we've got this tidal wave of change coming that we're just not ready to deal with.
Yeah. Yeah, that's going to be a big one. The job stuff for sure. I think that's going to be. We've talked about that a bunch of times on the show too. I think it's just.
What's your idea of timelines? How do you see this playing out?
That's a good question.
Have you thought about it?
I haven't really. Again, technically, most of the pieces are in place, other than some of the issues. And to your comment about the last mile, Yeah, we could have convoy. I mean, right now, today, with very little risk, we could have trucks convoying, put a driver in the lead vehicle, and have him convoying 10 trucks behind. That could be done today.
Right.
I didn't even think about that. Yeah, right. Of course, you just
Until some idiot tries to go, right, I'm not aware these are autonomous, so I'm going to merge in the middle of these huge big trucks, and it's like, yeah.
But still, that's disruptive right there. I mean, I never even thought. I always thought like full autonomy right away. But yeah, that kind of mixed mode. That's kind of like the you walk into a CVS and now there's 2 cashiers and 20
automated
ones instead of 10 automated or whatever. Right. Yeah. That's crazy.
Right.
Yeah.
Wow, that's really crazy.
But like I don't see, like, a lot of people saying, oh, it's going to be all over in 5 years. It's like bullshit.
No,
like there's no. It's going to take a generational change. So it's a 20-year thing. It's, at least, I think.
Well, from the society aspect, you're saying.
Yeah.
Yeah.
Oh, totally.
Yeah.
Wait, do you think people are just going to give up their cars and get an autonomous car?
Sign me up. I'm ready right now. I can go. I'm going to go to the bar.
Yeah. It is a generational thing. And, a lot of it will be driven by electric vehicles because in a city, electric vehicles make a lot of sense.
Totally.
When you get out into Kansas or Montana or, the middle of Australia.
In the middle of whoop whoop.
Right.
You still need gasoline. And so even though you can do that autonomously, the refueling is going to be trickier. So you might still have some drivers for some of those situations. But in the cities, it might happen, even though the cities are technically more challenging, it might happen faster because the need is greater.
Yeah.
It could. Yes.
Yeah.
Wouldn't disagree with that. But it's not going to be as quick and easy as people think.
Yeah.
So you were working on this kind of stuff at FRC, which is not First Robotics in this case. We did mention that before the show, but at the Field Robotics Center. So this is your PhD. How far did you take it? I mean, like, was that part of your?
Well, my PhD
thesis?
My PhD actually wound up being about meta design. It basically, my PhD dissertation was a method. It was based on genetic programming to design physical objects, and so.
I think I've seen stuff about that before. Like,
So I actually wrote I wrote a program to optimally design a walking robot to walk across a random field, and I also co-evolved the controller for it. So it evolved the body and the mind at the same time. Obviously, very simplified representation, but that's what my dissertation topic was.
Oh wow! So. Is someone going to be blaming you for like the robot uprising at some point? Is that
you mean Skynet? Honestly, when that movie first came out, I was very concerned about that. But it's been long enough ago, so I don't think they'll blame me.
Oh, okay, good. I was going to say, or maybe 6 years of doing a PhD beat it out of you. You're like, this is so hard. No one's ever going to figure this stuff out.
Well, there's some very high-profile people, Stephen Hawking and others, warning about the, artificial intelligence and everything else getting out of control. Do you see that actually being a problem?
You can argue it either way. And again, I haven't been, for the last 10 or 15 years, my focus has been on startup businesses and things like that. So I haven't been as engaged in the dialogue as I was previously. But I think you can make the argument either way. Either it can go out of control or it can't. And at this point, I just don't think we know enough to be able to know which way it's going to come down.
Well, I'll hang my things on the chopping block. I'm going to say it's not going to be as big a deal as people think.
That's Dave's favorite thing to do. We should also say Dave loves going against the predictions. Yep. So, yes, he likes saying "I told you so."
The doomsday. I don't think it's we're so far right. People say, once you reach a critical. What's the word? The critical point in the computer, it gets more powerful than the human brain, etc., or 100 times more powerful.
Singularity,
blah, blah, blah.
you mean, Dave?
The singularity thing or whatever it is. It'll just magically happen. No, I'm sorry, it's not going to just magically happen. We're not even close to have it magically happen.
I have to say, I know you said you're not going to be in charge of the robot uprising, but your next thing on your docket here, Cybernet Systems. I'm just saying
let's-
that's
well,
that's a little
I
close.
saw
yeah,
that.
That's
well,
a little
let's not
close.
talk about that. That was, you know what they say: if you can't say something good, don't say anything at all. So let's just
Okay.
leave that one
Okay,
behind.
we'll just let that go. Right. Okay.
But
So
yeah,
let's move on to the startup stuff because that's also very interesting, and we want to hear about your current company too. So how did you bounce out? I mean, so you got your PhD, you bounced out of there, and then what?
well, one thing I learned, and maybe I can credit Cybernet with one good thing, is that, and this might sound strange, but it turns out that technology after a while becomes easy. Because if you set out to solve a problem using technology, if you're good, you know at the very beginning you're going to be able to solve the problem, and then
Right.
you just do it, and you go, okay, I've solved this problem. And honestly, after a while, just doing the technology became boring to me. And one of the things I discovered, and maybe it's because I'm an engineer, is that I don't understand people. And every
Yeah, I get that.
interaction
Yeah.
every interaction with a person is unique and different, unpredictable, and a whole lot harder to deal with. And
Right.
so since I
So
like
messy. I don't. Yeah, I hate dealing with humans. So.
so I became more interested in that, and again, because of my background in robotics, again, back in those days, we were jack of all trades. You had to do the
Yeah.
mechanical stuff, the electrical stuff, the programming, et cetera, et cetera, et cetera. And that was very well suited to startups. I worked for a couple of big companies, and they try to pigeonhole you to doing one thing, and that did not work
Yeah.
well.
Right.
And I sort of migrated to the startup space. I've earned an MBA from the School of Hard Knocks in doing startups,
Yep.
but it's a heck of a lot of fun. Constantly learning, constantly doing new things. So for today, for example, I wrote a marketing piece. I talked with a supplier. I talked with my CTO about some ideas for product expansion. I took care of some financial stuff in QuickBooks. Typical day for a early stage startup CEO. It's
Right.
one
You're
thing
doing
after
everything.
the next.
Yeah. Yep. And you had enough time to talk to us, so that means you're doing something right. I mean,
Well, that means I'm skipping dinner.
oh, okay, sorry.
But,
But, yeah.
Civionics, which is a University of Michigan startup, is an industrial Internet of Things company. And basically what we do is we put intelligent wireless sensor nodes on pieces of manufacturing equipment. We extract information from the sensors, and then we look for changes in the information that's coming back that might suggest that there's a current problem or potentially a future problem with that equipment. And then we can alert the plant personnel that this is happening so they can then take corrective action before there's a downtime.
Right.
Interesting. How are you powering these sensors?
I'll answer that in one second. So, for example, in Southeast Michigan, we have a lot of automotive. And that's
Yes.
our first
Yep.
customer is one of the big automotive companies. And we are on several stamping lines in one of their plants. And what I've come to learn is that if one
As
of
in stamping metal parts?
stamping metal parts, like
Right.
the beds of pickup trucks and hoods and things,
Oh, yeah.
big stuff.
Stamping
Big,
machines are
huge,
amazing.
boom,
Yeah.
boom. Yeah.
Those things are so fun.
Yeah, so these stamping lines, every one of them that they have represents about 2% of their entire North American stamping capacity.
Holy crap.
Wow.
Okay?
Wow. Yeah.
And, they're 50-year...
They're a big deal.
Yeah.
If those things go down,
Yeah.
it's
Yeah, the lost revenue is about $1 million an hour if one of these lines goes down.
yeah.
Eeh. Yeah. Okay.
And
So,
and the equipment, in many cases, is 25 and 30 years old,
yeah.
and it doesn't have
Wow.
sensors. So, we've been on some of these lines. We've been credited with saving them 3 downtime incidents since we deployed a year ago, and that's only on 2 of their, dozen or so stamping lines.
Wow.
And so they're quite pleased with it.
How can you convince them to stop it for an hour so you can attach the damn sensor?
We don't have to stop. So right now,
Well, you're not putting inside the stamping thing, right? It's not like you're slipping
not
your
yet.
hand in,
Here
slipping
it
your
comes,
hand
here
out.
it comes,
Yeah,
quick,
right.
slap it on.
well, so two answers to the question, Dave. First of all, they normally only operate 20 out of 21 shifts a week. So normally,
Oh, okay, yes.
third shift on Sunday morning is available. Third shift, of course, starts at 2 a.m., and it's no fun to be at the
Of
plant
course
at
it
2
does.
a.m.
Yes. Been there, done that.
Yeah.
Yep.
So there's that. And we're not on the dies yet, but at some point, we probably will have some sensors on those. And so that gets back to your question of how are you powered? And a lot of our stuff right now is battery powered because in a situation like this, we're not talking about closed loop control. We're talking about degradation of systems. So these are things that happen over longer periods of time.
Long term, yeah. So you just
like a heartbeat
like a 5 times a day, it just pings back, and then you over a month,
probably, right?
you might notice.
Yeah, we're a little bit more frequent than that. Right now we're at 6 times an hour, and once things settle, we'll probably go to once an hour. But yeah, and at that point, we have battery life of 5+ years.
Yeah, exactly.
Yeah.
And you could probably send back the battery levels as well, right?
Yeah, we do that. That's one of the channels that we gather. Yep.
Yeah, that's great.
Cool.
That's really great.
So what sort of stuff are you sensing for? You're sensing for vibration. Presumably, you'd be on something like this, impact shock. To see that. Because it's a stamping machine, right? So you'd want to know the impact force, so you'd be sensing the G's and...
Yeah, so we're not doing that yet. I mean, the initial rollout was, as simple as it sounds, just temperatures and currents. Because that tells them a lot about the health of the machine.
Current, so like you're in line?
On what, the big stamping coils or what?
On everything, on the main motors, on the ones that care about the most really are the cooling fans. Because if you see the current to a cooling fan go away when your motor's operating, that tells you you've got a problem.
Yeah, that's real bad.
Yep.
So do you have to actually insert in line then, or are you just doing inductive sensing?
Inductive sensing.
Okay.
Oh, easy.
That's great too then. Yeah,
and
because
so,
you're not
clip it on.
interrupting.
So you don't have... Well, it's like the last line. So I was out there a couple of weeks ago. Actually, again, we're small, so I'm actually doing the installations myself. Matter of fact, I'm going to be there 6:30 tomorrow morning doing another one.
Hey, nice.
But we're actually
glamour.
For the most part, we do it while the line is hot. Now, on the 900 amp circuits, we have them shut that panel down. I'm not going to go near a 900 amp circuit.
Right.
But the other stuff, when you're doing current clamps, you can do it on a live panel as long as you're careful.
Yeah, of course.
Yeah, that's great. So I used to work in industrial, and I know that at least the people that I talked to, were incredibly allergic to wireless. They wanted, it was power plant stuff, but they hated wireless, even with I knew some people that were working on the, what's it called? The wireless heart, like the really slow wireless protocol that has all that stuff. What are you using for the wireless stuff?
We use 2. So the way we're configured is we have what we call leaf nodes, which are battery powered, and then we have what we call a cloud gate node, which is what provides the communication up to the cloud.
Okay.
So the leaf nodes and the cloud nodes communicate using 802.11.4, the Zigbee protocol.
Right.
Yeah.
And then
is that the 15? Isn't it 15.4?
That's it. I'm sorry, 802.15.4. Thank you. And then to go up to the cloud, we can either slot in Wi-Fi or 3G into our product.
Cool.
And what's so interesting about the factory is, as you guys were intuiting, there is some hesitance to open up those networks. So for the initial deployment, we did everything with 3G, and we're able to bypass plant IT.
Yep.
But
exactly.
Yes.
The engineering managers got what they wanted. They're seeing the value. Now they can go to plant IT and say, this has value, make it happen. So we're now having those conversations. Obviously, it's in our customers' best interest to be on Wi-Fi, not 3G, because then you don't have to pay for the data plan.
I just think reliability in obviously you can notice when something's not transmitting, but at some point they're going to be like, no, I need to know exactly what's going on here. So I think that's really what right now this is like a value add, it seems like, but I think what you'd hope for is that eventually it's such an integral part of monitoring that they're like, we need to have it. And that's where I'd think it would really become a critical, pinging every 10 minutes or else, or else line shutdown like the TP, the Toyota production system type of thing does. Yeah. Is there plans to move towards that or no?
Well, right now it's monitoring. If something goes wrong, they get alerts. One of the reasons they're very comfortable and we were able to deploy quickly is that we don't interface with their programmable logic controllers, their PLCs.
Oh, yeah.
We're independent from that.
Yep.
When we talk about interfacing with the PLCs, you start seeing some faces get screwed up. Because then there's a lot more risk, because then theoretically somebody can hack your system, push stuff to your node, which can then push it to the PLCs, et cetera, et cetera. So
yeah. And security is another. I mean, I would think at the stuff you're doing, it would be like industrial espionage of like how often something's stamping, that kind of thing. That would be the only piece right now. But what is the other security concerns?
That's one that we talk about internally. And, there was that large DDoS attack recently that was done by usurping a lot of IoT devices.
Oh, yeah.
But, I'm not really too concerned about that for a couple of reasons. First of all, we have custom hardware and we don't run an operating system. So the ways into our device are very, very limited. Somebody would literally have to know the schematics, our data formats, and everything else. And even then, they probably aren't going to get very far because, they would have to figure out how to reprogram the thing. And, so it would be an extraordinarily painful thing for them to do. And by the way, that's
is it security by obscurity?
In part it is.
In part.
Not if he says it on the show, Dave.
It's one of those things where, if you have an operating system on a device, or if it's a well-known device, people know how to interact with it. But our devices don't have web interfaces.
Right. It's not running Linux or anything like that, right?
Yeah. And they get back packets of a very specific format from our server. But again, that's all basically binary data. And if anything's even one bit off, it gets thrown out because it doesn't pass a checksum.
Yeah.
So it becomes really hard to hack something like that.
Well, and it is. I mean, it is sort of one directional, right? I mean, at least right now, it's mostly broadcasting back from the sensor node out. But do you have stuff going the other direction? Do you push firmware?
Yeah, configuration. There's configuration information that can be sent and stuff like that.
Okay.
But you don't want your competitor down the road to be reading your data and, oh, geez, they're stamping at twice the rate we are.
Right.
Right,
that would be the espionage.
Right. But all of the data going up is over HTTPS, so it's all encrypted in flight.
Right.
And once you're on the database, you can be hacked and somebody can steal your data, so you have to use best practices. But our banking stuff is on computers that are cloud accessible, right?
Yes.
So, if the U.S. Treasury and your bank account and my bank account can be on computers that are in the cloud, I guess their stamping data can be also.
Well, it'll remain to be seen. We'll see. We do have a lot of hardware hacker type listeners, so I'm sure they'll write in if they hear anything that's. I'm really surprised actually that there is an industry for this stuff though. Like with penetration testing for hardware, that's becoming bigger, and that's. I'm sure as you grow, that's something you would do anyways, right? I mean, you would probably hire those people for security audits, stuff like that.
Again, we've talked about that, and we literally can't figure. The only way we think somebody could really do damage is if they have physical access to our device in a facility, because then they would theoretically be able to reverse engineer it and figure everything out. But that's such a significant amount of effort versus being able to exploit a known password in a device that's got 5 million of them out there. Why would they bother?
Right. Or if you're going after a big car manufacturer, you go after their SCADA system, which has probably got much more value anyways, or whatever they use for DCS, whatever. So,
what is Techtown Detroit?
Techtown Detroit is the longest established startup incubator and accelerator in the city of Detroit. Techtown basically has 3 branches. It has a physical plant, the building. The first floor is used for startups. We have co-working space and meeting rooms. The other floors have tenants ranging in size from a 2-person law firm up to a publicly traded company, publicly traded on the London Stock Exchange, that is. And a lot of different activities happening. We have the Blocks group, which is actually unique in the entire country. It's a group that specifically focuses on building entrepreneurships in the neighborhoods. So,
that's great.
Even in Australia, Dave, I'm sure you've heard that Detroit has had a few challenges recently.
Oh,
Dave, have you heard that?
That's what I was going to ask about. At least we're not Detroit. It's Chris from Cleveland.
Yeah, when I was in Cleveland, Dave used to love the Cleveland promotional video, the hastily made Cleveland promotional video.
Cleveland, at least we're not Detroit.
Well, look up The Russian comedian Yakov Smirnoff used to do a routine in which he made fun of Cleveland. So look that one up.
Okay.
Right,
Actually,
okay.
that video was making fun of Cleveland too, but yeah.
Yeah.
But Detroit is geographically a very large city. And I hate to use such archaic units, but it's 140 square miles. So that's about 450 square kilometers or something.
Yes.
So it's geographically very large. And the Midtown region and downtown region are booming. They're as vibrant as any city in the world.
Yeah.
And Corktown, which is next to it, is doing very well. But that's only about 10, 11 square miles out of this very large city. And so the Blocks program is really focused on taking the processes, tools, and methods that we teach to technology startups and going to the neighborhoods and helping the neighborhood businesses, go from 3 jobs to 5 jobs and increase foot traffic and actually make vibrant neighborhoods again. And they're just doing fantastic work. It's been recognized. The actual grant money coming in to support it has been growing because people have been seeing the success.
I was going to say, is the state paying for this? Is the
less
city, the county, or whatever paying?
Less and less. Again, don't want to bore you with American politics, but Michigan is now being ruled by the Republicans, who basically don't like Detroit because nobody in Detroit votes for Republicans. And,
really? Okay.
Yeah, and so there have been issues with that. The funding from the state has been diminishing, but there's a not-for-profit entity in Detroit called the New Economy Initiative, which has been extremely supportive. The Skillman Foundation. Again, I don't work that group, so I can't rattle off all the names. But even some of the big banks, I think Bank of America has even supported that program because of the success that that program is having in the city.
Yeah. No, these like on boots on the ground type of organizations are great for funding small startups, small businesses, whatever. It's really good stuff.
Yeah. They have a retail boot camp program, which helps people who are doing garage retail and internet retail actually establish brick and mortar. It puts them through all the paces to understand if it makes sense for them. So some great stuff. And then the group that I work with is called the Labs Group, and we work with early stage tech entrepreneurs. And by early stage, a lot of the ones we work with are, just coming out of the ideation phase. We have an accelerator.
What's the ideation?
Ideation. So,
ideation.
Yes. Pre-prototype, pre-revenue.
So basically pitching on a PowerPoint deck, right? Not with anything else.
Yeah.
Right. Yeah.
Oh, okay. This is a buzzword I hadn't heard of.
Oh,
Sorry.
okay.
I'm out of the loop, obviously.
You should ideate on it, Dave. And cogitate.
Yeah, we run a program in the summer for college students and recent grads based on the lean startup methodology.
And Eric has been on the show.
Yep.
Yeah.
I don't know if I've ever met Eric, but yeah, certainly know him, know of him. And
That's cool.
We make them do a lot of customer discovery to figure out if their ideas make sense.
That's really healthy, actually. Yeah, because sometimes even when you have a prototype and you show up and you're like, okay, but who's actually going to buy it? So if you have that up front, that's very valuable.
Yep.
And that's probably that technology isn't the hard part kind of piece,
Absolutely.
Right? Yeah,
absolutely.
But it's also the killer of dreams.
Yes.
It's like you turn up with your widget and you're
some dreams are meant to be
not
woken
gonna
up
sell,
from.
son.
Dave. Yeah.
Sorry.
Yeah, see, and one of the reasons I like facilitating that class is, like I said, I'm a New Yorker by birth, and so for me, killing dreams is part of my DNA. So I have a reputation of beating on the students.
Hey, let me tell you how the things really are out here. Huh?
Yeah, so I've got a reputation for carrying the big stick, but in the end, the students usually, almost always, I think there's only been one in the last 3 years out of 90 who didn't see the value in the process.
Right. And so that means they're actually getting out and talking to potential customers, right?
Absolutely.
That's super important. Yeah. And if people are listening and they have that widget, go talk to some customers because you'll be surprised what you learn. It's crazy.
Well, let me make a plug. There's a website called Udacity, UDACITY.com. It's online classes. If you go to Udacity and sign up for an account, which is free, they have a class, and I don't remember what it's called, but just put in the word startup, and it's an entire class by
is it the Steve Blank?
Steve Blank on the startup, and there's some extremely good material there.
Yeah, Steve Blank is a longtime writer. People don't know he's a longtime writer about startups and stuff like that. And he does a good class. So
that's good stuff. So that's what we teach. And then we have our incubation program, which is more of a hands-on, one-on-one between the two EIRs. The other gentleman is Francis Glory and myself. And we work very closely with a small handful of companies, helping them try to figure out what to go next. Yeah, exactly.
Is that right? Okay.
Oh, and we just brought on a new entrepreneur in residence, Marlon Page. She just got married, though. I forgot her last name. Darn it. Anyway, Marlon, who was brought on, again, probably the only one like her in the entire country. She's an executive in residence whose focus is on building diversity in the tech startup community.
That's wonderful. That's really great. Yeah.
And so she comes out of a corporate career. She also started a program in Detroit called Sister Code, which was to teach coding to women between the ages of 25 and I think she said 85.
Nice.
A lot of times just so that they know what it's about so they're not scared by it.
Yeah, that's great.
And so she's a wonderful addition to the team.
Cool.
And so is that how you've been in the startup space for a while. Is this kind of how you discover, you've been at a couple different startups, is this how you kind of find the startups to work with as well?
Well, technically, that's what it's supposed to be. So, traditionally speaking, an EIR works with a source of IP generation. For example, a tech transfer office at a university.
Okay, yeah. Ann Arbor, right where you are.
Who's there? Well, in Detroit, it's actually Wayne State.
Wayne State. Oh, that's right, Detroit. Yeah.
But U of M's right around the corner from where I live. And so, typically an EIR will find a technology, help it along, and then take the technology out of the university, become CEO, and grow it up. That hasn't happened yet for either Francis or myself at Techtown. Civionics is actually a U of M startup, and I was introduced to them by a colleague of mine who, when they said we want to, the company started by doing a lot of contract engineering and government contracting, and what's called the Small Business Innovative Research Grants, SBIR. It's probably been on the show before.
That's right. Back in show 331, Zach Ferdine was talking about those.
Dave, I hope he looked that up and didn't know that off the top of his head, because if he did, I'm scared.
I did actually know that off the top of my head. So,
he probably does. Yeah.
It was a couple weeks ago. Come on, give me a break. But yeah, anyway.
But they said they wanted to try to become more of a product-based company and be able to have repeatable revenue. So a colleague of mine who knew them introduced me to them, and that's how I got engaged with Civionics.
All right,
that's great.
But
it's I can imagine that's how it usually happens, right? With introductions, knowing people, that kind of thing.
Yep.
So when like the tech transfer, I've heard about tech transfer before. I'm usually kind of wary of it, to be honest. Because I know that a lot of research happens at schools, but not necessarily like practical, like things that are going to be translate to actual solutions.
Well, and that's a good point. So let's get back to customer discovery for 1 second. There's sort of two ways that products come to the market. There's what's called customer pull and technology push. So customer pull is when a customer or an entrepreneur sees a need based on their experience, and they go about trying to build a business to solve a specific problem. Technology push, on the other hand, typically happens at universities where some guy with a PhD, and you got to watch out for guys with PhDs. They're all trouble.
Yeah, those guys.
Dodgy.
Dodgy. I got to remember that word. That's a good one. They think they're going to solve world hunger, and they come up with some wonderful technology which does something in their lab once. They write a paper about it, and then they're going to start a company, and they don't have to market it because it's so great. Everybody's just going to come to their... Right. That's technology.
And they'll raise $20 million on Kickstarter.
Yeah.
Or Indiegogo, because they don't have a real prototype. Oh.
Yeah, so that's technology push, and that's where Civionics was. It was really a technology push. There was this core platform that was actually developed to assess the health of bridges, and the question was, what can it do? And so the first thing I did for the company was customer discovery, and the original thought was to use it for building energy monitoring. And I found that nobody cares about energy monitoring. A bunch of people cared about energy management, but energy management normally means changing heating, ventilating, air conditioning systems, HVAC systems, and that's not what a tech startup does. But the beauty of customer discovery was while talking to, one of the tracks I went down was seeing if large factories cared about this.
Right.
And
also, who's got money to even possibly fund this kind of thing, I'm sure, right?
Yeah. And so while talking to a guy at a large factory, he said, I don't really care about energy monitoring, but can it tell me about the health of my equipment?
Oh, that's great.
Let's think about that. Well, guess what we're doing today? We're doing equipment health. And that's the beauty of customer discovery. If you go into that process with an open mind and you really listen to what the customers are telling you, you're going to learn more, in a few hours of doing that than you will, years sitting in your lab talking to yourself.
Right. And how did you
How
set up those
easy is it to
meetings?
get that, though?
Yeah.
Like, can you just call up a company and go, do you have to have contacts, or you just cold call them and go, hey, we've got
Hello, factory.
some wonderful tech. Can we come and talk to you
I'd like
and
to
see
talk
if
to
you'd
factory.
like our products?
Well, so Dave, the answer is cold calls are always harder than getting introduction, but it also has to do with how you preface it. If you pick up the phone and say, I've got this wonderful thing, the first thing going through their mind is sales call, and
Right,
you're not
snake
going to
oil.
get any place.
Exactly.
But the whole point of customer discovery, it's not about selling, it's about learning. And so that's when you appeal to people's ego. So what I would tell people is I would say, look, I know everything in the world about wireless sensor systems. I know absolutely nothing about building energy management. Based on what I've discovered, you're an expert in this field. Can you teach me?
Stroke,
Yep.
stroke, stroke.
Yeah, people love and what's really cool.
They do.
Yeah, they love to talk about it, and what you find is if you hit upon a pain point, you can't get them to stop talking.
Yeah. It's funny too, because the way you describe this is what I tell young engineers. That right there is also networking. Like getting someone to talk about their problems or like what they're working on. Like that's also how you just get to know people. That's like, and then eventually they'll be like, oh, by the way, I need to hire someone to do this stuff anyways. Oh, okay, yeah, I'm that guy. That's great. No, that's really great. And so it was just it was cold calling, but it was not. But it was like with a purpose, with the ego piece. Yeah.
Yeah. Yep.
Man, that's awesome. That's really
Nice.
great. And how many people do you have to talk to in order to kind of finally get to that point of?
I actually didn't do as much as we normally recommend. I only got through about 75 customer discovery interviews before we discovered that.
What
75.
What do you usually recommend? My goodness.
We recommend a minimum of 100, and that's to get started.
Whoa.
Holy
Wow.
crap.
Convincing 100 companies to let you come and talk to them, that's a full-time
year.
job for
That's
a year.
Yeah.
That's a year's full-time job.
Well, we give the students in the summer 10 weeks. They're supposed to be doing a minimum of 2 a day. Now, obviously, if it's a B2C model, it's much easier to get the interviews. But then we tell them they have to do 250.
Oh my god.
Gotta set the bar high.
That's masochistic. That's sadistic. I always get this backwards. Yeah, that's wow. That's whoa. So 100 for B2B, which is business to business, 250 for B2C, which is business to consumer.
Well, I mean, the reality is this: if you've never done it before, you're going to screw up the first 10 of them so badly they don't count. But by the end of the first 10, at least you're going to know the questions
You'll
to
be
ask.
good. Yep.
Right.
And
well,
then
people
you're
can
gonna
go listen to our first 10 interviews, and yes, they will agree that they're pretty bad. So.
And then the
Wow.
next 15 or 20, you're going to figure out that your original idea sucked, but you really need to be pivoting and asking about this. And by the time you get to number 70, you have got a pretty good idea of what the market wants, what the needs are, what the pains are, and then you can start honing in and asking more detailed questions. You can start, figuring out what sort of sales model they want, what sort of distribution channels they want. And so the later calls could get much deeper because you've done a lot of learning, and you can, at that point, speak their language, understand their pains, and have a much better conversation.
Wow. That's so, and you also shifted your targets, right? Because I'm guessing at the beginning you were doing the energy people, and then you started talking. You're like, oh, I need to talk to factory people.
Yeah, it was
so that shifts too.
generic buildings. Then I looked at co-working spaces. I looked at large campuses. I had a wonderful conversation with a guy who's responsible for energy management at Microsoft.
Wow. Like all the servers and stuff too.
Yeah, Yeah, and
Whoa,
the amount of electricity they use there is a mind-boggling number.
Oh, yeah.
But they do an incredible job of tracking it and being aware of it.
Yeah, and a lot of them are switching to renewables too, right? To reduce their costs and stuff like that. Man, that's nuts. Could you give us a quick, because we are kind of running out of time, could you just give us a quick idea of what you say? Is this like an email, or is this like a call, or like what does it sound like when you're starting to do this kind of thing?
Well, normally I would do an email first before the call, and it's typically something to the effect of, I'm an entrepreneur, I have a startup idea in this space. I'd like to get 10 minutes of your time to learn from you, what some of your challenges are, to see if our idea makes sense. But the key thing is you don't tell them your idea, because anybody who's nice enough, to say, yes, I'll talk to you, if you tell them your idea, they're going to say, oh, that's nice. And that's not what you want to hear. You want to hear your baby is ugly.
Yeah.
And so a lot of this is teaching people, how to have these conversations. And for many of your listeners who I'm sure are technically inclined and are, probably introverted by nature, it's not impossible, because again, I'm an engineer, I'm as introverted as the next one, but it's a skill that you can learn. And if you learn it, it just allows you to become a much more effective engineer, because you actually solve the problems that people care about, not the ones that you think they care about.
Right.
Yep.
Man, that's great. That's really great.
That's brilliant.
Yeah. I imagine that people that get good at this too, like I've talked to some business owners, stuff like that, where they're just like, I have so many business ideas that I don't even know what to do with it. Like when you find someone that started a couple of companies and stuff like that, but it's because they understand how to talk to people. They understand how to like figure out what their real pains are. And then they're like, oh yeah, that's a business. That's a business. That's a business. Right. And,
And obviously, the longer you're in industry, the better your understanding of these things are, because you've just seen it and you know what the challenges are.
Man. Do you go around and teach this stuff other than at Techtown? Techtown?
Primarily Techtown. Ann Arbor has a boot camp. I've been involved with that. Occasionally at U of M, I guest lecture a class here and there. I've guest lectured at the engineering school and the law school. So yeah, a little bit. It's fun.
That's great. Yeah. Well, I didn't expect it to take this turn, but this has been very interesting stuff.
That is
really
that is very interesting. I don't think we've had
people
anyone talk about that aspect
take note.
before.
This is really important stuff.
We have had a lot of similar discussions about this sort of stuff, but that particular aspect has never really come up.
Yeah. And
so
Gerry, is that in the Steve Blank course as well? I mean, is that like if people sign up for that course, is that the kind of stuff they'll learn there?
Oh, absolutely. Okay.
Right.
Yeah. Another one. There's a PDF book you can download. It's all of 80 pages. It takes 30 minutes to read, called Talking to Humans.
I have that one. That's a good book. Yeah.
It's a really good book, and again, it gives you ideas of how to have these conversations.
Yeah, that's smart. Well, Gerry, thank you for being on. That we ran through robots up to startups. Is there anything else people should know about you, or what you're working on, or what you're interested in?
Well, I think what people need to know is that you were right, because when we were talking about this, I said, you can't get me to talk for more than 10 minutes, and we've been at this for 90. So well done, gentlemen.
We're very good at this.
Never. Yep. Yeah, we've done a couple interviews now. So yeah. Well, Gerry, thanks for being on. Where can people find you and your company's stuff online?
Well, Civionics is www.civionics.com, and that's spelled Civionics, sort of like the word avionics, but civil and electronics.
Oh, yeah.
Techtown Detroit is techtowndetroit.org. And then we also have you can Google me, Gerry Roston, Roston. One of the advantages of an uncommon name and having been on the internet for as long as I have is if you Google me, the first, 50 pages are 90-some% me. So I'm very easy to find. And then we have a personal website, pairofdocs.net. You can track that one down as well.
Okay.
Sweet.
Well, thanks for being on. We appreciate it. And
it's been great, Gerry.
Hope to talk to you again soon.
My pleasure. Really enjoyed it.
Thanks, mate. Catch you next time.